Next question. Real-time data processing architecture. Your company needs to build real-time data processing architecture to handle streaming data from IoT sensors, online user interactions, and financial transactions. Wow. The system must process the data in real time, perform aggregations, transformations, and make the processed data available for both operational data dashboards and machine learning models. How would you design this architecture? What technologies and frameworks would you use? And how would you ensure the latency, fault tolerance, and scalability? Okay. So first of all, the problem with this question is the following, is that if you're designing the real-time data, like real-time for analytics, aggregation and transformation, your tool set is very different when you're designing that for the operational database. Because for the operational database, you are interested in the different metrics than you're interested in the aggregational. But let's say, I think it still kind of would be doable, right? So how I would do something like that would be following. So we have our source, and then we introduce a centralized data bus. In this case, let's go with Kafka or Red Panda. I believe that's also a thing. So we have, so this is our data source, and that could be, so data source 1, data source 2, and then data source 3. So now all of this data source first of all goes into Kafka, right? Say we don't think of how they do that. Most likely there is like a producer which produces the data and writes into Kafka. So we don't care about that part. So the data is in Kafka. Now what we need to do, we need to basically like feed for the things differently. So what we can do, we can introduce like Logstash, which is which would read from Kafka into itself and then would write into Elastic Search, right? Would write into it, and then this can actually go into Kibana dashboard, right? So this would basically so all of that we could consider to be as operational. So if I take this one and I take this one around in here, and I just say go up and be without any background, operational, right? So this is our operational part. Now, if we want to do for like machine learning stuff and data warehouses and things like that, we have, like a process which could be Apache Flink. It also can be Apache Spark. I mean, to some degree, you could introduce some database, but I don't want that because this would require explanation. Some database which is able to process data in real time. So now here you have a state, and here you actually can process the data in this micro batching operations, and then you would push the result into your data warehouse, and from the data warehouse you would send into your ML workloads, right? So that sort of would be, and then from the data warehouse again you could go into the reporting, right? So that's sort of like our setup. So now if I take all of that and I share that as an answer, let's see how that goes. Here illustrates robust real-time data processing architecture designed to handle diverse data sources such as the sensors, user interface, financial transactions. Let's break down your architecture and discuss components. So the data sources, okay, then the centralized message broker, Kafka Red Panda. You choose a central message broker. That's a great choice. Managing due to high throughput. Access the buffer between data processed and the data consumers. Then the data procedures framework is Apache Flink, Apache Spark. And for the operational pipeline used to process transform data streams from descending them from the Elasticsearch, performs ETL transformation, enrich the data, Elasticsearch. Yeah, and that's sort of like visualization and the data warehouse for having the data in there, and then reporting. So low latency, that's what we expected. Default tolerance, yes. Scalability, yes. Separation of concern by segregating operational data from the analytic workloads. You optimize each system and purpose, correct. Consideration for future optimization. Schema registry. Right. So schema registry is actually an interesting product. So the schema registry comes, let's go here. Oh, shoot. So the schema registry is actually a Kafka's thing, which you would introduce this additional process right here. And it would be sort of like a database process, schema registry. And what to do before sending a message to Kafka, it would need to validate if the message is correct. So sort of like, kind of like this, I guess. So data source checks the schema registry to check what the schema is, and then sends, and then sort of like only then, you know, is allowed to send and things like that. And then the same thing, sorry, I put it in the correct place. And the same thing right in here, the schema registry is checked for the consumers, and also the schema registry is checked in here for the consumers to make sure that the data is good. Now, I think the schema registry actually adds a lot of additional complexity around, which needs to be measured. And basically you need to make sure that it's really, really useful to have there. But yeah, I mean, it's possible, but that's the schema registry part. And as always, I'm forgetting the monitoring and alerting. I always never add that. I kind of like, I assume that that's by design already included in there. And then of course, security and compliance, which is a different beast on its own.